Chapter 4.5 Exponential and Logarithmic Equations. Okay, let's check a theorem which is equality of exponents. Equality of an exponent. We have an equation here, and this equation contains exponential form. And the base of this equation are the same. The base is b. So in order for this exponential equation to be same, the exponent has to be same, isn't it? Because the base is the same. So the corresponding parts, the base are the same, so that exponents should be same. So for example, for the exercise number 1, we have an equation. The left side of this equation is an exponential form. The exponent is x plus 1 and the base is 2. So why don't we make the right side of the equation 32 an exponential form with the same base 2. So 2 to the x plus 1 is equal to 32 is, okay, let me divide this 32 into product of 2. So 2 times 16, 16 is 2 times 8, 8 is 2 times 4, and 40 is 2 times 2. So actually the number 32 is 2 to the 246, 6th power. Sorry, 2 to the 5th power. So 32 can be written as 2 to the 5th power. So since bases are the same, we can set the numerator, the exponents same, then minus 1 each side, so x equals 6. So this is how we can, I'm sorry, x is 5. Minus 1 each side, so x is 5. So this is how we can find the solution of an equation contained in the exponential form. Okay, let's try the next one. Okay, in this exercise, example number 2, this is an equation containing an exponential form, but the base is 5, but the number 40 cannot be an exponential form with the base 5. So in this case, we can take logarithm on both sides. Okay, let me rewrite this so that we can take a logarithm on both sides. The logarithm, base can be 10, logarithm on both sides. Then we can take this x out. So this will be, the x moves to the front, so x times logarithm of 5 is equal to logarithm of 40. Then logarithm 5 is a number, so we can divide each side by logarithm 5. So logarithm 5 moves to the right, goes to the denominator of the right hand side of the equation. And logarithm 40, you can use the calculator to get the value of logarithm 40 and logarithm of 5. So this is approximately equal to 2.3. So if you cannot make the same base, then take logarithm with base 10 so that you can use calculator to get the numbers. Okay, let me try another example similar to this. So if we have 4x is equal to 25, then take logarithm on both sides. So log base 10, log base 10. Then the exponent x moves to the front. 25. And then divide each side by logarithm, log of 4. Yeah, 25 is 5 squared. So you can move square to the front, but we need to know the value of logarithm of 5. So anyway, since we are using calculator, then use the calculator, then you will find some number for this. Okay. Or we can simplify this. Okay, let me erase this. So logarithm 25 is log 5 squared, log of 2 squared. Then you can move the exponent 2 to the front, so 2 log of 5 or 2 log of 2. So 2 to cancel out. So finally we have logarithm of 5 divided by logarithm 2. Okay. Example 3. Here is an equation containing exponential form. Okay, the bases are different, so we can take logarithm on each side, or you can take natural logarithm or common logarithm. So in this case, let's take natural logarithm. So 3x minus, this is 2x minus 1 is equal to 5x plus 2. So let's take natural logarithm on both sides, ln. Then this exponent and this exponent can move to the front. So 2x plus 1 moves to the front. Then we have ln 3. The right side is x plus 2, put parentheses, ln 5. And then we can use distribution so that we can collect the x terms. Let's distribute like this. So there will be 2x ln 3 plus ln 3. Do the same thing. So x ln 5 plus 2 ln 5. Then let's put x terms together. So why don't we move this one to the left and move this one to the right? Then we have 2x ln 3 minus x ln 5 and 2 ln 5. Move this ln 3 to the right and change the sign. Okay, from here, the left hand side is a like term. So let's combine the like terms. So you can write it as 2 ln 3 minus ln 5x. So that is equal to 2 ln 5 minus ln 3. Okay, next we can divide each side by, okay, wait a minute, I think I made a mistake. The exponent is 2x minus 1. 2x minus 1, but I wrote it plus 1. So let me change this one to minus. So that should be minus. So once you move it to the right, it should be minus, right? Okay. Minus. Alright. So this is minus. Then once you distribute, this becomes minus. And move it to the right, and this will be plus. Oh, sorry, this is plus because we distribute these two. Okay, and then once we move this negative minus ln 3 to the other side, then this will be plus. So this will be plus. Okay, sorry for the mistake. Okay, now we can divide each side by the coefficient of x on the left side of the equation. So that is ln 5, the right side is ln 5, 2 ln 5 plus ln 3 divided by this coefficient. So 2 ln 3 minus ln 5. And then using our calculator, this will be approximately equal to 7.3. So what we did is just took ln on both sides. Either you can use ln or logarithm, still fine. Anything's fine. You will get the same answer. Example 4. Okay, this equation contains exponents. One is x and the other one is negative x. Okay, first of all, let's get rid of this denominator 2. So multiply each side by 2. Then the right side will be 6. Okay, if you rewrite this, the negative x can move to the denominator, so it looks like this. Then in order to remove the denominator, we can multiply the equation by 2 to the x. This is negative x. So you can make it positive by moving the exponential form to the denominator. So the exponent is positive. So in order to remove this, we can multiply the equation by 2 to the x. So I will multiply this by 2 to the x. So okay, multiply by 2 to the x. Okay, okay, let me rewrite this. Okay, so once we multiply the equation by 2 to the x, then we can distribute. So 2x times 2x plus 2x times over 2x, and then this is, okay, 2x6. And the first term is x plus x times, this is, the exponents are x and x, so we can add these two, so it will be 2x, and x plus x is 2x. The second term cancel out, it becomes 1, and the right side can be written as 6 times 2 to the x. Okay, from here, let's substitute, let's move the right side to the left. 2x minus 6 times 2x plus 1 is equal to 0. Okay, we have an equation that is equal to 0. And then, okay, this exponent is 2. And then, this equation is a square form. So if we set, x squared as u. Okay, look at this. If the exponent of the first term is twice the exponent of the second term, then we can set this 2 to the x is equal to u. Then this will be square of 2 to the x, so this will be u squared. So always, if the exponent of the first one is twice the exponent of the second one, then always set the exponential form is equal to u. So 2 to the x is equal to u. Then the first term will be u squared, always. So this will be u squared minus 6u plus 1 is equal to 0. So we have a quadratic equation. So since we have a quadratic equation, we can use quadratic formula. Okay, do you remember the quadratic formula? Okay, here, let me write it here, quadratic formula. Quadratic formula. So if we have ax squared plus bx plus c is equal to, okay, ax squared times bx plus c is equal to 0, then the solution x is negative b plus minus square root of b squared minus 4ac over 2a. So this is the solution. So using this quadratic formula, let's find the u value first. So u is equal to negative b, so negative times negative 6 plus minus square root of b squared minus 4ac divided by 2a. So u is equal to positive 6 plus or minus square root of, okay, 36 minus 4 is 32 over 2. So u equals 6 plus or minus square root of 32 over u over 2. And 32 is 2 times 16. Okay, 32 is 2 times 16. So 16 is 4 squared. So u plus or minus, okay, 2 times 4 squared. So finally, u is equal to 6 plus or minus 4 moves to the front, divided by 2. And then if you divide both numerator and denominator by 2, then we can cancel out 2. So that becomes, okay, let me factor out the numerator. So it's easier. Factor out the numerator. Divide by 2. So u is equal to, we can cancel out 2, so plus or minus 3 plus or minus 2 square root of 2. So we just found u, but u is not the answer because the u is the expression for this 2 to the x, this exponential from 2 to the x. So replace this u with 2 to the x, so that is equal to 3 plus 2 square root of 2. Actually, it's a plus or minus, right? Plus or minus. Okay, then from this, let's find x. So in order to find x, we can take logarithm on both sides. So let's take a logarithm on both sides. Okay, should I move? Okay, just leave it. So take logarithm on both sides. So 2 to the x is equal to logarithm of 3 plus or minus 2 square root of 2. Okay, then this exponent x can move to the front. And the right side is still unchanged. And then divide the equation by logarithm of 2. So log of 3 plus or minus 2 square root of 2 divided by logarithm of 2. Okay, then we can use the calculator. So one is 3 plus 2 square root. 3, use the plus so that you can find one answer. And if you use minus, then you can find another answer. Okay, logarithm, be careful with this one. Logarithm x, then this x has to be greater than 1. X has to be greater than 1. And 3 minus 2 square root is, okay, this one is positive. This is positive. So we can use this one. So we can get an answer for this also. Then this will give you two answers, which is, okay, if you use a calculator, then it's gonna be negative 2.54 and positive 2.54. Example 5. This is an equation containing logarithm. So logarithm equation. X is inside the logarithm, so we have to get rid of this log. So there are two ways to remove this log. Okay, using a definition, okay, the base is 10. So we can make an exponential form with the base 10. So this 10 and then the exponent of this base will be the other side, 2. Do you remember this? Okay, do you remember this? Okay, logarithm base b of x equals, say, y. Then this means, okay, let me write it here. This means base b, write an exponential form, and the exponent of the base b will be the other side, y. Then that is equal to inside the logarithm. So we can use this formula. So base 10 to the second power should be equal to inside the logarithm. Now we have removed the logarithm, so we can solve for x. This is 100 is equal to 3x minus 5. So move minus 5 from right to the left, then it will be positive 5 plus 5. So now 105 equals 3x. Divide each side by 3, then there will be 35 equals x. So x is 30, x is 35. Okay, when you get the answer, make sure that the logarithm, inside the logarithm should be greater than 0. So let's check whether this is correct. Check. So once we check 35, the logarithm base 10 of, okay, 35. So 3 times 35 minus 5. Okay, let me rewrite this. Okay, let me write the expression inside the logarithm. 3x minus 5. Then 3 times 35 minus 5. This is greater than what? Greater than 0. So 35 is okay. So 35 is the solution for this logarithm equation. Okay, there's another method. Okay, let me write it on the right side. Another method is this. In order to remove the logarithm, we can, okay, let me write here. Okay, we can, okay, the base of the logarithm is 10. The base is 10. So why don't we make an exponential form with base 10 on each side? So this will be the exponents of the exponential form, and 2 is the exponents. So by definition, we can get rid of this base 10 and all the way. Let me use different color. Let me use a different color. So based on the definition, we can remove this, so that what we have is 3x minus 5. 3x minus 5 is equal to 10 squared. So 3x minus 5 is equal to 100. So the answer is still same. 105 divided by 3, so it will be 35. So the property that we use is this. Here is base b, and the exponent is logarithm base b of x. Then this is equal to x. Then the answer will be just x. Example 6. This equation also contains logarithms, but there are more than one. So if there are more than one, we can put the logarithm together. Okay, here is one of the properties. So we have, if we have x log of ab, then we can separate this into two logs. Log of a plus log of b. So since we have a logarithm with the same base, you can multiply this a and b together. A and b together, because this is an addition. Okay, so we can, so here, this is, and then also minus. Here's another one. If the logarithm is the log of a over b, then this is a minus. This becomes a subtraction, log of b. So if two logs with the same base is a subtraction, then you can put a and b together, make a quotient a over b. So this is a minus, and then so that we can make a quotient. The logarithm of 2x will be the numerator, divided by x minus 3 will be the denominator. Okay, now we have one logarithm, so we can take base 10. So let's take a base 10 from here. Let's take a base 10 each side. So the left side will be just the rational expression. 2x over x minus 3 is equal to 10. And then multiply each side by x minus 3. So 2x is equal to 10 times x minus 3. Simplify this. 10x minus 30. And move 10x to the left. Then it will be negative 8x is equal to negative 30. Divide by negative 8. So positive 30 over 8. So x is, now reduce it, 15 over 4. So we have x value 15 over 4. And then check whether this makes the expression inside the logarithm to 0, negative. So 15 over 4 is a little less than 4. Little less than 4. So little less than 4. So 2x. We have a 2x and x minus 3. So 2x is positive. And x minus 3 is also positive. So this is okay. Okay, let me explain again. So we have an equation 2 of x and logarithm of x minus 3 is equal to 1. So this 2x is positive because x is a little over 4, a little less than 4, and even this is positive because x is a little less than 4. So 4 minus 3 is positive. So this is the solution. Okay, check. Okay, this equation contains natural logarithm, 3 of them. So why don't we change the right side of the equation, because there are 2 of them. So let's combine the 2 logarithms from the right side. And the right side is an addition, so we can put them together by multiplying 2 expressions, 2x plus 2, and then multiply by x minus 2. Okay, so we can put this one together. So that goes inside the natural logarithm. Then this will be ln 3x plus 8 is equal to natural logarithm of, okay, if we simplify this, that will be, okay, let's use the distribute FOIL method, 2x squared minus 4x, this one times this one minus 4x, and then this plus 2x, the last term, 94. Then the natural logarithm 3x plus 8 is equal to ln 2x squared. Combine these 2 like terms, minus 2x minus 4. Okay, and then okay, so we have natural logarithm on one side and another one on the right side. So we can easily eliminate this natural logarithm by taking the base e. Okay, why do we take the base e? Well, the natural logarithm, if the logarithm with the base e of x, this is equal to natural logarithm x. That's the definition of the natural logarithm. So if you have an ln, then that means that's the log of base e. The base is e. So we can take e each side, then what we have is only this. So the equation will be 3x plus 8, and the right side is 2x squared minus 2x minus 4. Okay, so from this equation we can now simplify. So let's move everything to the right. So 2x squared minus 2x minus 4 minus 3x minus 8. So this is equal to 0. Then combine the like terms, 2x squared. We have 2 like terms, so minus 5x. Here's constant terms, so minus 12. Then can we factor this trinomial on the right side of the equation? Okay, let's try. So this is 1 times 2, and this 12 is 3 times 4, 4 times 3. And then put the negative sign on the larger side. So this is negative 8x. This product is 3x. The sum is negative 5x. And this is the same as the second term. So yes. So this trinomial is the product of x minus 4x times 2x plus 3. Okay, you can make it x times 2x, still okay. So x should be, okay, from the set the first factor equal to 0 and second factor equal to 0. Then from the first factor, x is, wait a minute, why get no x here? It should be x minus 4 only. So from the first factor, x equals 4, or we got another one, x is negative 3 over 2. Okay, so we have 2 values. We have to also check, we gotta check whether these numbers are valid. So if x equals 4, let me write it here, x equals 4 or x equals negative 3 halves. So let's check it from the original equation. Okay. Okay, if x equals 4, then let's check this one. If x equals 4, then this is positive. This is also positive. 4 minus this is positive. So 4 is fine. 4 is fine. If x is negative 3 halves, this is equal to negative 1.5. So if you plug in this number in this expression, then this becomes negative. So we don't allow negative, so we have to eliminate this one from the solution. Because, let me mention it again, if logarithm of x, the condition is always this one has to be, x has to be greater than 0. Since if x equals negative 3/2, this x minus 2 becomes negative, so we cannot allow this value. So the only answer is, the solution is x equals 4. Okay, just a note for this one. Okay, for this exercise, let's find the velocity when t is 5 seconds. So plug in 5 for t. And then write the equation. Okay, from here we want to find v. V is inside the natural logarithm. So we have to get rid of, remove the natural logarithm. So before we do this, let's remove this coefficient, negative 175 over 32. So why don't we multiply each side by the reciprocal of this, reciprocal of this one. So there will be negative 32 over 175 each side times 5 is equal to, the right side is just natural logarithm. Okay, then the left hand side is, you can reduce this 5 and the denominator 175, so that is negative 32 divided by 35. Okay, and then now we simplified. So why don't we, how do we eliminate this, get rid of this natural logarithm? Simple, right? Simple, because we can just take the base e, because natural logarithm has base e. So why don't we take e in each side? So we have an exponential form on the left hand side and the right hand side. Then the right side becomes, okay, the left side is this one. The right side becomes only this expression, 1 minus v over 175. So from this equation, let's find v. So minus 1 each side. Take minus, subtract 1 from each side. So that we have negative v over 175. And then from this, multiply each side by, where's minus 1? Yeah, minus 1. Okay, let's multiply each side by negative 175. So multiply each side by negative 175. So the right side is just v. So v will be the, okay, let me rewrite it. So v is equal to negative 175 times e to the negative 32 over 35 minus 1. So this is the expression for the velocity. So using a calculator, then v will be approximately equal to 104.83. So this should be, is it what, feet per second? Something like this. So in this case, when we solve an equation containing natural logarithm, simplify the equation so that you have natural logarithm on one side. Then once you have a natural logarithm on one side, take base e on each side so you can remove the natural logarithm. Then the rest is simple. Just solve for v in this case.